All right, hey there, fellow coders. Welcome to this next session of our series of videos that talk about the FreshVote app, which we are building. If you haven't seen any of the previous videos to this, I'd recommend that you go back to get some context as to what these things are that I have on my screen here, so you understand going forward exactly what we're building. So what we've done in the previous video was we outlined the requirements and we pulled out all of the nouns. And here are the 8 nouns that we pulled out. So now we are tasked with taking these nouns and turning them into the database schema, the model, the exactly what the back end of this system is going to look like in terms of what data we're storing and how we're storing it, etc., etc. So let's dive into that right now. So these are going to be what are called the entities, if you want to talk about hibernate and whatnot, and we'll get into all of that stuff much later. Well, I shouldn't say much later, actually, fairly soon, because then in the next videos, once we start building out this stuff in code, we're actually be making use of hibernate. So actually, I lied. Well, we're going to be talking about that pretty soon. So yeah, these are going to be the entities, the database tables, but not every single one of these values or nouns here are going to represent a database table. We have 8 nouns. Does not mean we're going to have 8 tables. As I alluded to in the video previous to this one, some of these nouns are just properties that belong to a table. So let's talk through exactly which ones should be tables and which ones should be properties. And also, I'm also going to do a little bit of combining here because, anyway, you'll see what I mean. So business owner. What is a business owner? Whenever you've used a system, whenever you've used an application, right, you are essentially, a very common term that's used is a user, right? So a business owner is going to be a user of our system. Visitors, as we go down this list, visitors are also going to be a user of our system. So really what I'm saying here is these two things, the business owner and the visitor, are kind of the same thing. They just represent 2 different roles in the system. Okay, and the word role is an important one because it has to do with security, authentication, and authorization. Specifically, a role refers to authorization. Okay, and I'm going to get into this in the video, upcoming video, which will be fairly soon, talking about Spring security using authentication and authorization and what those 2 words mean in the context of the application. So for now, I'm just going to say, to keep things broad, business owner and visitor represent a user. Okay, so let's do that. Let's have because it's usually there. I don't think I've ever created an application that didn't have a user table. Okay, so yeah, that's usually going to be a table that you are going to be working with, and we're going to call it users. And I did say I would depluralize everything in a previous video, so I'm breaking my own rule here, but there's a good reason for it because in the I'm going to be using a MySQL database, and a lot of other databases have a reserved word for user. So the singular user is actually a reserved word, so we need to add an S on there so that we can still call it user, but users, so that we don't collide with that keyword, because that really complicates things and it messes up your code and everything when you use a table name as a reserved word. It's like saying I want to make the table name if. Okay, we talk about programming languages, if is usually a reserved word. So same thing with user here. So that's why I am breaking my own rule and adding an S to make a plural. Typically, I would say don't do that unless you're running into a name collision type situation here. Okay, next thing is page. So we've combined business owner and visitor into one table called users. We'll get to that table, the design of it in a second. So now page. What is a page, right? That's a pretty broad term. That's almost like saying app, right? We talked about the word app and how we weren't actually going to bring that forward because, well, all of these database tables together, when we create them, represent the app itself. So we don't really need to have an app table. That would be kind of silly. Page is almost on that line of thought. A page or a web page or whatever, usually when you hit that word, you don't create a page database. Again, these are very broad terms. So then you have to say to yourself, okay, what is a page? What is it that it's what is a page representing in this case in our app, right? So a page is essentially the business owner wants to have a space that you can go to, a URL that they can send you to that will represent essentially all the feature requests, right? You want to see a list of all the feature requests that are pending, ones that are in progress, ones that are being considered, ones that are closed, ones that are, open, ones that are in development. All these different statuses will be on a page, right? So really, this concept of a page is pretty abstract, and really I would almost say a page represents many features. Okay, because we want to present, I even said that earlier, I want to present many features on a page. So really, we're just talking about many features being listed here. So a page is just a view, it's just a way to present the data. And the data is really what we're talking about here. We're talking about the database schema. We're talking about the data, okay? So really, a page is just how you display that data. So in other words, let me see, I'm gonna give it a red. No. Okay, we're not necessarily going to have a page. We have features that are going to be represented on a page. Make sense? So, cool. I just said feature. So let's have a feature table, because that is really the heart of our application, right? People are going to be suggesting features that the business owner should put into their app, whatever it is that their app is, whether it's an app that, a social media app or a dating app or a financial planning app or what have you, whatever app the business owner has, these are features that are being suggested. So this is a core thing. So definitely there needs to be a database table for the feature. Okay, so we've covered business owner, we've covered page in terms of processing it, we've covered visitor, we've covered feature. So now title and description. This is where I'm getting into the concept of properties versus tables. Okay, so because feature is so critical, it is going to be its own table. It is the heart and soul of this entire thing, other than users. It's going to be the heart and soul. So that makes sense to be its own database entity, database table. Title and description. These are really a title. What is a title? Because the word title on its own doesn't really tell us much, right? Can we have a database table just called title? It just doesn't really tell us very much about. So what the heck is title mean? Well, it was used in the context of the title of the feature. Okay, features will have titles and descriptions. I think it might have even said that in the wording. A feature will have a title and description. So right there in the wording it says if a feature has a title and a description, the word has means something in programming. It means it is a property of. Okay, so in other words, title description represents title, description, are going to be properties of a table. So let me give some context to these tables just so we can see visually the tables, right? So yeah, title, description are just properties of a feature. So therefore they should not be tables on their own, they should be properties of an existing table, which is the feature table. Okay, cool. So now we've processed title and description. What about comment? Should a comment, I mean, when you say the word comment, it does give context, right? You understand what a comment is. You just don't know what a comment is for, right? You're leaving a comment for what, right? So this is where you're looking for the term has a, right? Has a comment. And in this case, features will have comments. Yes, they will. So then you might be tempted to say, oh, well, then because Trevor said earlier, if a feature has a comment, then you can go ahead and write comment in here. But there's a trick in there because a feature should have a title and a feature should have a description. Yes, I completely agree with that. But a feature does not have a comment. It has many comments, right? You can have many people leaving many comments on a feature. So although you would be tempted to make comment a property of feature, it almost could be, but it's actually, there's a relationship there. So there can be many comments, right? And not just many comments for a feature, but many comments left by many users. So when you have this kind of relationship thing happening here where a user has a comment on a feature, an X has a Y on a Z or a Z or whatever. It's you see this relationship thing. So as tempted as I would be to say comment here, I believe that comment should be potentially, and this could change in the future, it should be its own table. Okay? Boom, bada boom, bada boom, bada boom. Cool. And I should preface this by saying this design can change at any moment during the actual programming process. This is just us making our best effort, our best guess as to how this stuff is going to look and how it's going to be designed. But I don't think I've ever worked on a project that's a large enough project that's gone on for more than a day or 2 days. Really, maybe even more than 2 days. If the project will take you more than 2 days to build, your design could change, right? With 2 full days of coding, if you put in 8 full hours times 2, so 16 hours of coding into one project, and you're a senior level programmer, your design could change even after 2 days. So this is our best guess as to what it's going to look like. But yes, just know this is not set in stone. This can change, and it's not going to be the end of the world if it changes. In fact, it's par for the course if it changes. All right? Just keep that in mind. So, okay, comments are going to be in their own table. Status. What is status? Should status be its own table? Again, just the word status. If I wrote status as a table, well, that doesn't really tell me anything. Okay, there's status, and then there were different statuses, right? Well, there was an open status and a closed status and an in progress and a this and that. So should there be a closed table and a status and a open table and a in progress table? Well, that seems like way too many tables, right? The databases will grow over the course of an application, but that's to start an app with like 12 tables right away, it can be a little bit ridiculous, especially if this app isn't meant to change the world or anything like that. This isn't a crazy, huge scale app. This is a fairly simple app. So to just start creating tables at will doesn't make a whole lot of sense. And the other check you can do is if you're not sure if something should be a table or not, if you can only think of one or two, I would even say just one property of that table. So we have title, description inside a feature. If that was it, if there were no more properties here that we could think of for feature, I would be unsure if feature should be its own table. Okay, 2 isn't ridiculous. I've seen database tables that have 2 properties and that's it. Fair enough. But if it's just one property, if it was just title and that's it, we have a feature table that has title and that's it. That would not work, in my opinion. So the same thing with statuses. If you had like an open status and a closed status, you'd have the open status, and then you'd have like a yes or no. Is it open or not? Then you have like a in progress status, and is it in progress or not? So that's just one. That's not right. That's not good database design. So okay. So then, what is a status in this context, right? Well, status: open, closed, in progress. In consideration, whatever. These describe a feature's condition, state, sort of, whatever, what have you. So really, this is a feature has a status. Okay, when someone suggests a feature to be built into an app, they're going to suggest that it's probably going to be in the open state, right? It's been opened and it's there. Okay, so a feature has that state. It's an open status. And then if the business owner looks at that feature and says, let me start considering that, the status will change to in being considered or in consideration or whatever. So really the status is a property of a feature, right? And it can change, right? It changes at will. And there is a relationship in that that we need to remember. It's a property of a feature which belongs to a user. Are there any other relationships there that would throw us a curveball that I can think of? Does a status just belong to feature and that's it? I'm trying to think, should it be its own table? What other, if status was its own table, what properties would it have? Right? It would have the status would be, there would have to be some sort of property that defines the current state of the status. So maybe it would just be state. Right? Okay. Are there any other properties that would exist on the status table? Well, we have to have a relationship to tell it what it belongs to, but that I don't count relationships in terms of to be considered when it comes to the my rule of if it only has one property, then it's not shouldn't be a table. I'm ignoring relationship properties there, and we'll get into that probably in the next video because this one's going long. So a status, is there anything else that a status would have other than just a textual description of what that status is? I can't think of anything, right? Which is why I'm pretty sure a status should be a property of a feature. Okay, if I could think of a bunch of things that would belong on the status table, status has a XYZ, then I would consider it being its own table, but I can't think of anything. So I think that status should be part of the feature table. Okay, so there we go. We sort of iterated through. We started with 8 things, and we're down to 3 tables. Right? Now, there was one thing I forgot to think about or mention before, and that was upvoting and downvoting, right? So, and I think maybe upvote on its own and upvote, that kind of is a noun when I think about it. It's really what an upvote or a downvote represents is a vote. And a vote absolutely is a noun. So I kind of missed that in the last video. And that's okay if we miss nouns, during this process talking it out, and especially during the design phase or the implementation phase of our design, we probably would have caught that and said, "Oh, the whole point of this is to vote, and we haven't captured anything about votes in here. What the heck are we doing?" So really, there should be votes, right? So we probably should have some sort of a voting table. Okay, so let's consider the word vote for a minute. Should vote be its own table? Well, what is a vote? A vote is either a yes or a no. One thing, yes, no. Is it an upvote? Is it a downvote? I vote for this. I don't vote for this, right? And that's pretty much it. So again, it's like, well, hold on a second. A vote doesn't sound like it should be its own table, right? Because what other properties would a vote have? Someone is voting for something, and someone is the one that's voting. So really, it's like, okay, well, hold on a second. A vote is made by someone, a user, and a vote is a vote for something, a feature. So really, vote is kind of unique here because vote really defines a relationship between 2 tables. This is called a many-to-many association here. So a user can have many votes, and many votes can be placed on the feature. So it's a one-to-many and a one-to-many type relationship. So really, vote should also be its own table. But you see what I did there? It's not its own table in the right that I've given all the other things tables. It's its own table because it defines a relationship between 2 tables in a many-to-many aspect. That's a curveball here that I'm throwing at you. When you have a many-to-many relationship, you're going to have what's called a join table. Okay, and really it's gonna define whether or not, is it an upvote or a downvote. So I put upvote here. That will be a Boolean value. So in other words, upvote will be a yes or a no. If it's a yes, then it's an upvote. If we have a vote that's an upvote that is a false or a 0 or whatever we use to describe it, that means it's a downvote. So we're capturing the state of the vote with just the one property. But like I said, with status, why the heck is this its own table? Well, this is because it's a relationship between 2 tables. In other words, the user places an upvote or a downvote for a feature. So it's joining 2 tables. Again, many-to-many relationship there, which is why I have created this in the structure that it currently is. Many-to-many relationships require a join table, and that's why we have a join table here. Okay, so that's, like I said, that's the only curveball where you would have a table that might only have one real property. Sometimes join tables have no properties other than just the relationship data. Right? So with many-to-many, if this didn't have upvote and this was the join table, this would just have a user ID and a feature ID, and that's it. There'd be 2 properties in the table. So like I was saying before, the relationship data part of this is not to be considered when you are trying to decide when to create a table or not, except in the case of a many-to-many, because if you have a many-to-many, you need a join table. That's just the way it is. That's just how that's how a many-to-many relationship is represented in a database with a join table. Okay. Now to further that, a one-to-many or a one-to-one relationship, because there's three types of relationships, right? One-to-one, one-to-many, many-to-many. Okay, those are the only three relationships that we have in a relational database. One-to-one, one-to-many, many-to-many. One-to-one doesn't require a join table. One-to-many doesn't require a join table. Many-to-many requires a join table. So you see that? That's the only exception to our rule here. Okay, cool. So there we go. There we have sort of the final. Well, I don't want to call it final because, like I said, at any point this can change. But this is our current iteration of what the tables should look like. And all these tables are missing are the well, I should say the comment should have something defining the comment itself. So the actual comment, I don't know, text, I guess. The comment text. And then, okay, so hold on a second. Let's talk about this. How come there's only one property in here? Should a comment contain more information, or is this a join table situation, right? Because now I'm looking at this and I'm saying, well, hold on, I'm breaking my own rules that I just flat out told you. This only has one property that I can think of, right? So a user leaves a comment. How would we store that information? Well, the comment information would be stored in the form of some sort of a varchar, probably a string format, whatever, that they would type in, and we would store that in a table. It makes sense that text needs to be stored somewhere, so, we could store it into a table, but maybe it should be stored right to a feature. Well, hold on a second. Does that mean that a feature can only have one comment? Because if we stored a comment inside of a feature, we've joined it in such a way that you can only have one comment in one feature, and that doesn't make sense. A feature should have potentially many comments. Okay, so there's the many relationship, but that maybe it's just one to many. Okay, so maybe this is not necessarily a situation where we definitely need another table. I don't know, but we need to store the text somewhere, so it does make sense that if a feature can have more than one comment, then yeah, we do need to have some sort of, but maybe we can put it, where else could we put it, right? But hold on, a user is the one leaving a comment, and can a user only leave one comment? No, a user can leave many comments, right? So this is a situation where it's another many-to-many, okay? Users can leave many comments, and none of those comments can map back to, you can have, a feature can also have many comments, right? So one-to-many, one-to-many, therefore, this is a many-to-many situation between users and feature. So there you go. It's another join table. It's another many-to-many relationship. So it's interesting how this stuff takes shape, and how this stuff can change, and how you can trick yourself into doing one thing or another. And this is what makes this process confusing, right? I've been doing this for 12 years professionally, but I've more or less been programming since the age of 10. Okay, I'm 35 right now, or soon to be 35. I don't know how old I am. So yeah, what is that? 35 minus 10? It's 20, not 25 full years of programming, because certainly I took breaks there when I was 10. I was doing other things than just programming when I was 10 years old. But I more or less started this process when I was 10. So, let's just say 2 decades I've been doing this for, okay? I've been programming for 2 decades. And you can see me still like, should I have done that? Should I not have done that? Like, the reason why this is such a difficult process is because really there could be many answers. There's no real one perfect solution, okay? There might be, but that's really hard to narrow down to the perfect solution. And then you're just going to be sitting in a state of, oh my God, I don't know, did I do this right? Maybe I should think this through and spend the rest of my life thinking about the design of this database to make it perfect. No, that's not how software development works. That's not how your employer would want you to work. That's not how, if you were to go and do this as a contractor, that's not how the person who's hired you to do the work would want you to work. This is a process of best guess. This feels good enough. Let's go now with the design and let's start building something and see what happens. Okay, because really there are many solutions. There are many, many, many solutions. Some are horrible solutions, and you're going to find that out real quick, why the solution just won't work, right? Some solutions are just wrong, and you're not going to figure it out until you start programming. Some solutions are pretty good, but they might have performance issues in the long term. Okay, so you might see a situation where it works right now, but later on when there's a whole bunch of load on the database, and there's a whole bunch of users, you might realize, oh no, this is not a good database design anymore. Okay, that happens when you start to get into, when you break up your databases and you normalize like crazy. I won't get into that right now. Sometimes you need to de-normalize for performance issues to get rid of those performance issues. Okay, so although a solution works now, it might not work later, right? So there's a whole bunch of solutions, and some can be right now and wrong later. Some can be wrong right now and therefore probably wrong later. Some will be right now and right later, but not amazingly, not perfect, because maybe there's still issues, maybe there's still little things that you could tweak here and there. So this is what makes this process a little bit very difficult, I should say, not a little bit difficult, but very difficult for especially new programmers, because they think that there's only one solution. There's not. There's not one solution, which is why I said this could change, right? This could work right now, but it won't work later. So always keep that in mind when you are building this stuff out. You can go in circles and circles and circles trying to make it perfect, but that's just not the real world. You're not going to get the perfect. The best thing you do is your best guess. This is what feels right. I think, given all of the stuff I know, this is the best design. You could, leave a comment and ask for help somewhere, from someone, from a peer, from whomever. Ask for help, definitely. Don't just go off on your own rogue and think you know everything. Ask for help. But once you've come to a conclusion, more or less, that you feel safe with, just go and code it. Nothing's stopping you. You can always change it. Okay? Cool. So I won't go any deeper into that. So hopefully this video's gone much longer than I intended. So the next video, maybe we will start to identify the relationships between these tables, and then we'll get into the actual coding process to actually turn these tables into actual tables in code. Okay, so thank you very much for watching. Don't forget to subscribe in the link below if you're watching this on YouTube or any other platform that allows you to subscribe, because there's a ton more videos coming your way as part of this series where I'm going to be building out, showing you exactly how to build a real-world application from scratch using the Java language for free. Okay, so subscribe below if you can. Turn on that notification bell so that you know exactly when new episodes are live and you can check them out ASAP. And otherwise, thank you so much for watching. Can't wait to see you in the next episode. Take care of yourself. Happy learning. Bye for now.